Hi, this is Mrs. KJ here with 6.01 Electrochemical Processes. Unit 6 is about electrochemistry. So hopefully you can break it down and see that it's talking about electricity as well as chemistry. Many chemical reactions involve the transfer of electrons from one substance to another. The movement of electrons also defines an electrical current. So in your house you have electricity, and that's just the movement of electrons. So in one way or another, many chemical reactions can produce electrical energy. Likewise, electrical energy can be used to drive chemical reactions. In this unit, you will examine electrochemical processes, how they can be used to produce electricity, and conversely, how electricity can be used to elicit useful chemical reactions. You will look at the technologies involved in electrochemistry, including voltaic cells, batteries, and electrolytic cells. Electrochemistry produces useful technology. Many chemical reactions involve the transfer of electrons from one substance to another. Electrical current is the movement of electrons, and many chemical reactions can produce electrical energy. Electrochemists study the relationship between electrical energy, and chemical energy. They develop technologies for producing energy from the chemical reactions and for driving chemical reactions with electrical energy. In this lesson, you will get an overview of electrochemical processes. Goals for this lesson: describe electrochemical processes, discuss how chemical energy is converted into electrical energy, discuss how electrical energy is converted into chemical energy, define an electrochemical cell. The electrochemical process: transfer electrons through electrochemical cells, produce chemical energy, produce electrical energy. On slide 3 is your student guide, and for the student guide, that is a student guide. There you go. Put it in my Word document and just kind of cut it down to the main objectives for the unit, the first paragraphs, and this lesson's objectives or goals, and then the keywords and pronunciation. So electrochemical cell is an apparatus that allows the conversion of a chemical reaction to electrical flow, or vice versa. Electrochemistry, the study of the interaction of chemical reactions and electricity. Oxidation, the process in which substance gains oxygen, so oxidation, oxygen, or more comprehensively, loses electrons during a chemical reaction. Redox is the term that is used as shorthand for oxidation, reduction reactions. And reduction is the process in which a substance loses oxygen. So in case you haven't noticed, oxidation and reduction are opposite. Oxidation means the substance gains oxygen. Reduction means the substance loses oxygen, or more comprehensively, gains electrons during a chemical reaction. Now, if you gain electrons, are you going to be more positive or more negative? You're going to be more negative, right? So chemical becomes more negative because electrons have a negative charge. Therefore, its charge is reduced, or lower, or more negative. So the first time you hear this word, people always get confused because they think, oh, reduce, get rid of. Well, we're gaining electrons because we're reducing the charge. We're becoming more negative, and that's why gaining electrons is called a reduction. It reduces the charge. Chemical energy can be converted to electrical energy, and vice versa. Interconversions of chemical energy and electrical energy take place every day. For example, when a car starts, the initial energy to ignite the burning of gasoline comes from the battery. The battery contains chemicals that react and produce an electrical current. You may have jewelry that is plated with gold or silver. And plated just means that it's covered with gold or silver. In making that jewelry, a chemist used electrical energy to drive a chemical reaction that deposited gold or silver onto another, cheaper metal. MP3 players, cell phones, and laptop computers have rechargeable batteries. A chemical reaction in the battery produces electrical power to run the device. When the battery runs out, you plug the device, or the battery itself, into an electrical outlet. The electrical power drives the chemical reaction in reverse, which recharges the battery. So your battery has chemicals. The chemicals get used up to power your MP3 player. When the battery runs out, you plug it in, and the electricity forces the chemical reaction to go backwards to build back up those chemicals so you can play your MP3 player again later. The study of the relationship between electricity and chemistry is called electrochemistry. Every day we use things that depend on the conversion of chemical energy and electrical energy. The basis for electrochemistry is the redox reaction. So redox, reduction, and oxidation, redox. When copper is placed in silver nitrate, a spontaneous oxidation, reduction, or redox reaction occurs, producing silver metal. What happens if you place silver in a copper nitrate solution? After 20 minutes, no reaction occurred. Silver can oxidize copper, but copper cannot oxidize silver. And there's reasons for that, but right now they just want you to know from this slide that silver nitrate reacts with copper to form a coating of silver metal. And the silver nitrate, again, reacts with copper to form that coating of silver metal. So we have our wire, and then we put in the solution. Okay, so we put in the silver nitrate. So our wire is copper. This blue liquid is silver nitrate. And what happens is the silver basically comes out of the blue solution, and it goes on top of the wire. So that's all pure silver sitting on top of it. That's pretty cool, isn't it? And if you notice, the color of the liquid, the silver nitrate, also changed because the copper is moving around as well, and there's all kinds of stuff going on. But basically, you can have a metal, you can plate it or cover it with another metal. Redox reaction involve the donation and acceptance of electrons. What about other redox reactions? When zinc is dipped in blue copper sulfate solution, okay, so we have our blue copper sulfate solution, and you can see the piece of metal up here. Okay, so originally this whole piece was this silverish color because it's zinc. Okay, and as you can see, it looks like it's getting more hairy. And what do you notice about the liquid? The liquid's getting clearer because the copper is coming out of the solution and the copper is attaching itself onto this zinc piece of metal. When zinc is dipped in blue copper sulfate solution, copper accumulates on the zinc and the solution's color fades. The following reactions take place. All right, so we had our zinc on the piece of metal and it's a solid. Some of the zinc becomes aqueous, so it goes into the water solution. And now look, the zinc has a +2 charge because 2 electrons came off of it. So this is called an oxidation. It lost electrons and now it's more positive. Here's what's going on with the copper. The copper started out in the aqueous solution, okay? And it was +2. Well, then these 2 electrons from the zinc, these 2 electrons hopped onto the copper atom, and then it became just copper. What is the charge of the copper I have highlighted right now? Nothing, right? It doesn't give a charge, so it's 0. Well, it was +2. 2 minus 2 is 0. So the copper's charge was reduced, which is why it's called a reduction. It gained electrons. It went from +2 minus 2 electrons to a charge of 0. So the charge is less. The charge was reduced. We call it a reduction. Each of the above is called a half reaction. So all this is going on at once. We just split it up so we can say, where are the electrons coming from? Where are the electrons going to? The transfer of electrons from zinc to copper takes place on the surface of the zinc metal where the 2 metals touch. The copper crystals grow out from there as the reaction progresses. So I added to the notes, metal can plate onto or cover another metal in a redox reaction. When zinc is dipped in a blue copper sulfate solution, copper accumulates on the zinc and the solution's color fades. The following reactions take place. The zinc lost electrons, so it was oxidized. The final zinc product, right here, will have a more positive charge, +2, than the original zinc, which has a charge of 0, because it lost electrons and is more positive. The copper, on the other hand, gained electrons, right? We added electrons, so it gained electrons, so it was reduced. The final copper product will have a more negative charge than the original copper reactant because it gained electrons and it's more negative. In this example, it went from +2 to 0 because +2 plus a -2 equals 0. Metals have a reactivity series with respect to redox reaction. So remember at the very beginning it talked about how silver can go on to a certain metal, but that metal can't go back onto silver? Here's the reason for it. Okay, we have a list of the metals, and lithium is the most active, the most easily oxidized. In other words, it loses electrons most easily, whereas gold is the least active, and therefore it's not going to lose electrons very easily. Chemists have observed which metals will donate electrons and which elements will receive electrons in various spontaneous redox reactions, such as the cadmium-silver nitrate reaction and the zinc-copper sulfate reaction. They have developed an activity series for various metals in redox reactions. According to this table, lithium is the most active and the most easily oxidized, the element most likely to donate or lose electrons. By contrast, gold is the least active and most difficult to oxidize, the element that's most likely to gain or accept electrons, right? If you're not going to get rid of them, you're going to take them in order to have a full outer shell and be stable. Remember me saying that like first semester? The whole reason that all these reactions are happening, it still all goes to you want a full outer shell in order to be stable. This table enables you to determine the type of oxidation reduction reaction that will occur when any two metals interact in a chemical system. So I added to the notes some metals gain electrons while others lose electrons. According to this table, lithium is the most active and the most easily oxidized. So in other words, it's going to get rid of its electrons. Gold is at the bottom, it's the least active, it's not going to oxidize. Instead, it's going to gain or accept them and be reduced. So, and therefore, AU will be reduced. So the top of the list gets oxidized, the bottom of the list gets reduced. What is an electrochemical cell? The principles of an oxidation-reduction reaction with its transfers of electrons are the starting point for understanding electrochemistry. Electrochemical cells interconvert chemical energy and electrical energy depending on the type. They have many features in common. They use metal strips as electrodes. The strips are either in the same solution or in separate solutions that are connected. Oxidation-reduction half reactions occur at each electrode. A wire allows the flow of electrons. Ions flow through the solution to maintain neutrality. Electrochemical cells can be divided into two types. There's voltaic or galvanic cells, and this is a spontaneous redox reaction creates electricity, or an electrolytic cell. Electricity drives a non-spontaneous redox reaction, electroplating. So spontaneous means it's just going to happen on its own once you put the chemicals together. An electrolytic cell needs electricity. And why? Because it's not spontaneous. It won't just happen on its own. And this is used for electroplating. So electrolytic uses electricity for electroplating. All right, and I'm actually just going to copy this on here because there's a lot of good information. So I'm going to copy that onto the note. So like I said, I just added that slide onto the notes. And then let's look at the electrochemical cells. And so a voltaic cell versus an electrolytic cell. And there's a few things to note, especially if we look back here. It says, all right, they use metal strips. Yep, metal strips, check. They're either in the same solution, so here they're in the same solution, or if they're in a separate solution, they're connected. So see this tube, it's connecting them. Oxidation reduction half reactions occur at each electrode, okay? And ions flow through the solution to maintain neutrality. So again, two different setups. This is the voltaic cell. This is the electrolytic cell. We'll talk more about them. How can redox reactions produce electricity? The half reactions in the cadmium-silver nitrate reaction occur together on the surface of the cadmium. However, oh, and just so you know, cadmium is just a metal. Okay, so this CD meaning cadmium. However, if you could physically separate the two half reactions and provide a path for the transfer of electrons, then the movement of electrons would produce electricity. All right, so my time's going to run out on this video. We will start up here again in the next video.